So in this problem here, we have the integral from -2 to 3 of 3 over x minus 1 minus x all squared. Now, first of all, it's important to recognize that there is a vertical asymptote at 1 because of that denominator there. And secondly, if we look at the bounds, we're going from -2 to +3. We're going to integrate across the asymptote. That's not allowed. So we have to recognize that because we're integrating along an asymptote or up to an asymptote, so you got to break this up into, first of all, you have to do the limit notation, and then we also have to break this up into two separate integrals. So the integral from -2 all the way up to the vertical asymptote of 1 has to be done separately from the integral from 1 to the endpoint here, and in this case is going to be +3. So those two areas have to be done separately. Okay, so I'm going to need a limit because I'm going to integrate up to an asymptote. So I need to use my limit notation. So I'm going to have the limit. I'm going to use t. It's going to approach the vertical asymptote at 1. In the red area, though, I'm going to approach it from the negative side. So then I'm going to integrate from -2 to 1, okay, I'm going to put down t in my notation of 3 over 1 minus x all squared dx. Okay, that's going to be that red area, plus, because I'm integrating along an asymptote, I need to use a limit notation again. I'm going to go to 1. This time I'm going to approach 1 from this side. So that's going to be from the positive side like that. And that integral is going to be the exact same integral with different bounds from t, which is 1, to +3, and 3 over 1 minus x squared dx. Okay, so at this point, I'm going to anti-differentiate these expressions, keeping my limit notation. So I'm going to anti-differentiate this expression. So I'm going to have 3. That's x to the power -2. So we end up going from power -2 to power -1. So I'm just going to write it like that. I have an extra negative, divide by the -1 power. But because there's also this extra negative here, I need to remember to divide by an extra -1. So those negatives are going to end up canceling out. Be careful of this one because of all those extra negatives. It's really easy to lose track of those. Plus, again, I'm going to use my limit notation. T is going to approach 1, this time from the positive side. The nice thing about this is I'm going to get the exact same antiderivative. Okay, that negative in front of the 3 is from the power of -1. And this extra -1 here is from the embedded -1 coefficient on the x. And this one here has bounds from, we're going to start at t, which is 1, all the way to 3. Okay, so that's going to represent the green area there. Again, just be careful with those extra negatives. I'm just going to cancel them out. And I'm going to end up with the limit as t approaches 1 from the negative side of 3 over 1 minus x. So I'm just going to plug in my t. So 1 minus t minus 3 over 1 minus -2. Okay, so that's going to represent that part. Put that in brackets. Plus the second part I'm going to do t approaches 1 from the positive side this time. Okay, and I'm going to plug in my bounds. Okay, again, those negatives are going to cancel out, so I'm going to end up with 3 over 1 minus 3 minus 3 over 1 minus t. Okay, so I'm going to now evaluate my limit. I'm going to plug in the 1 into my expression. I get 3 over 1 minus 1 is 0, and I'm approaching 0 from the negative side, minus 3 over 3, and then plus, I'm going to evaluate this limit as well. I'm going to plug in my bounds here. Let's use some brackets here. I end up with 3 over negative 2 minus 3 over 1 minus 1 is 0. This time I'm approaching it from the positive side. I've got this backwards here. Since I'm approaching 0 from the negative side, 1 minus 1 is going to end up being bigger than 0, because remember that t is going to be approaching 1 from the negative side, so it's numbers smaller than 1. So there's going to be plus here. And for this one, when I plug in the 1, I get 1 minus 0. This time I'm approaching 1 from the positive side. So 1 minus a number slightly bigger than 1 is going to give me a positive 0 here. Okay, so then this works out to be 3 divided by positive 0 is positive infinity minus 1 plus negative 3 over 2. Negative 3 over 2 minus, this is going to be approaching 0 from this one should be from the negative side. Positive 0. Sorry, this is negative 0, right? Because I'm plugging in numbers bigger than 1, so 1 minus a number bigger than 1 is going to be negative. There we go. So that's going to be minus negative infinity, and then that becomes infinity minus 1 minus 1.5 plus infinity. This works out to be infinity. Okay, so those two, the area that is unbounded there is an infinite area.